Hello everyone, welcome to today's session. In this session, we are going to begin one of the most important topics in computer science, algorithms. Before we start programming, before we learn data structures, and even before we write a single line of code, we need to understand how to think logically. That logical thinking is what algorithms are all about. By the end of today's session, you should be able to answer questions like what exactly is an algorithm? Why do we need algorithms? Where do we use algorithms in our daily life? What is pseudocode? And finally, why is algorithm design so important? Let's begin. So first, let us understand what an algorithm actually means. An algorithm is simply a step-by-step procedure for solving a problem. Think about it this way. Whenever you follow instructions to complete a task, you're actually following an algorithm. For example, if I ask you to prepare a cup of coffee, you don't randomly mix ingredients. You follow steps. First, we'll boil water. Next, add coffee powder. Then sugar. Finally, milk. Every step happens in a specific order. This is exactly what an algorithm is. In computer science, instead of making coffee, we solve problems. An algorithm accepts some input, processes it according to certain rules, and produces the required output. One important thing to remember is that an algorithm is not the program itself. It is only the logic behind the solution. Later, this logic can be converted into code using any programming language like Python, Java, or C++. Now, you might wonder, why can't we directly write programs? Why spend time designing algorithms? The answer is simple. Algorithms help us solve problems in a systematic way. Instead of guessing the solution, we know exactly what steps to follow. Algorithms also improve efficiency. Imagine searching for one student's registration number among 10 students. It is easy. But what if there are 1 million students? Choosing the right algorithm makes a huge difference. Algorithms also improve accuracy. Every single step is clearly defined. The chances of making mistakes are much lower. They also automate repetitive tasks. Whether it is sending emails, calculating salaries, recommending videos on YouTube, or processing online payments, all rely on algorithms. In short, I can say that algorithms are the backbone of modern computing. Let's now understand the main purposes of algorithms. The first purpose is problem solving. Large problems become easier when we divide them into smaller steps. The second purpose is automation. Once an algorithm is written, computers can perform the task repeatedly without human intervention. Third is efficiency. Good algorithms reduce execution time and memory usage. Fourth is reusability. Suppose you create an algorithm for sorting numbers. The same algorithm can sort exam marks, employee salaries, customer ID, or product prices. Finally, scalability. A good algorithm should continue to work efficiently even when the amount of data becomes very large. Every valid algorithm must satisfy certain characteristics. So let's discuss them one by one. First is input. An algorithm may take 0 or more inputs. Second is output. Every algorithm should produce at least one meaningful result. Third is definiteness. Every instruction must be clear. There should never be confusion about what needs to be done. Fourth is finiteness. An algorithm cannot continue forever. It must stop after a finite number of steps. Fifth one is effectiveness. Each step should be simple enough that it can actually be performed. Finally is efficiency. A good algorithm uses minimum execution time and minimum memory. So remember this point because later in this course we will compare algorithms mainly based on efficiency. Algorithms are not limited to computers. We use them every day, like making tea, cooking rice, withdrawing money from an ATM, searching contacts on your phone, booking movie tickets, shopping online, installing mobile app, even logging into Gmail follows a sequence of steps. Can you identify the inputs and outputs in such example? For example, ATM card. Input will be the ATM card PIN withdrawal amount. Output, it will be a cash and updated balance. Every system follows predefined instruction. So this is an algorithm. Next, let's understand one example in detail. Suppose you open Google Maps. What happens behind the scenes? First, you enter your destination. The application detects your current location. Then it calculates multiple possible routes. After comparing them, it chooses the fastest or the shortest route. Finally, it displays directions. If traffic conditions change, it recalculates the route automatically. Notice something interesting. You simply entered a destination, but internally, many algorithms work together to give you the best route. This illustration shows the complete navigation process visually. Whenever you see a route changing because of traffic, road closures, or accidents, algorithms are continuously processing new information. So Google Maps is not just showing a map, it is solving an optimization problem every second. Next, we'll see why algorithms matter in computer science. Algorithms are everywhere in computer science. Search engines use search algorithms. Banks use transaction processing algorithms. Artificial intelligence depends on machine learning algorithms. Healthcare uses prediction algorithms. Social media platform recommends content using recommendation algorithms. Cybersecurity uses encryption algorithms. Online shopping websites recommend products using algorithms based on your browsing history. Without algorithms, none of these applications would find efficiently. So till now we got an idea about what is an algorithm. So next we'll move on with what is pseudocode. Before programmers start coding, they often write pseudocode. Pseudocode is simply writing the algorithm in plain English. It is not a programming language. There are no syntax rules. Its purpose is to explain the logic clearly. For example, start, read two numbers, add them, display the result, stop. This is easy for everyone to understand. Later, the program converts into the actual code. Students often confuse algorithms with pseudocode. Remember this simple difference. An algorithm is the actual solution or logic. Pseudocode is simply one way of expressing the logic. Think of it this way. Algorithm is the recipe. Pseudocode is writing that recipe in simple English. Finally, code is preparing the actual dish. So usually we express algorithm in terms of either pseudocode or flowchart. Pseudocode is represented using control structures like while, if, then, else, for, case, etc. Why design an algorithm? Why we need to design an algorithm? So before writing code, why should we design algorithms? Because good planning saves time. Algorithms should provide systematic problem solving. They should improve efficiency. They help manage complex problems. So if we have complex problems, we can break down the large problems into the smaller sub-problems and we can save it. Then it can be reused for different situation. So we already saw an example in the previous slide. And finally, professional software companies spend considerable time designing algorithms before coding begins in order to eliminate the human error. So in this session, let's quickly summarize what we learned in the session. We learned what an algorithm, that an algorithm is a step-by-step procedure for solving problems. Algorithm accepts input, processes them, and produces some output. We discussed their characteristics and purpose. We also saw several real-life examples like making tea, withdrawing cash, navigating with GPS, etc. Finally, we understood that what pseudocode is and why algorithm design is essential. In the next session, we will study different algorithm design techniques and learn how to analyze their performance. So finally, we just see the recap. So we saw what is algorithm, what is the purpose of algorithm, what are the different characteristics of algorithm, what are the different applications and the real life example. So the algorithm, we saw it is nothing but a step-by-step process in order to solve a problem. And the purpose is so it solves problems efficiently as well as accurately. Some of the characteristics of algorithm are input, output, definiteness, finiteness, effectiveness, and efficiency. And we saw the various applications like GPS. So apart from that, the algorithm can be used in daily routine life such as banking, AI, healthcare, GPS search engines, and the various e-commerce platforms. Some of the real-time examples that we saw here is the Google Map. So it can also be used, some examples we can give it as pre-preparation. So withdrawing money in the ATM machine, online shopping where every day we use like Amazon, Flipkart, and traffic signals. So in the traffic signal also we it follows some algorithms. So we just got an idea about algorithms. So in the next session, we'll move on with the analysis.